Hello, this is Mrs. Workman. Find the volume of the cone. In other words, we want to find out how many cubic millimeters it would take to fill this cone. To do that, we're going to use the formula V equals pi r squared h times 1/3. Now, if some of that formula looks vaguely familiar, this part of the formula, pi r squared, is the area of a circle. We remember that from before, and we notice that part of a cone is a circle. Let me go back and rewrite this. Volume equals 1/3 times pi, and I'm going to write that r squared as r times h. This may help us fill in the dimensions. Pi, 1/3 times pi, times radius. This is the radius of the circle, given as 2 millimeters, times the radius, 2 millimeters again, times the height. This is the height of the cone, which is given as 10 millimeters. I think we're going to reach for the calculator now. We're going to use the pi button and multiply pi times 2 times 2 times 10 divided by 3. When we do, we're going to get an answer that is about 41 9/10. And as far as the dimensions are concerned, we have millimeters times millimeters times millimeters, and that's cubic millimeters. The volume of this cone is about equal to 41 9/10 cubic millimeters. Hello, this is Mrs. Workman. Find the volume of the cone. Round to the nearest tenth. The volume of a cone looks like this. Volume equals 1/3 pi r squared h. To help this formula look not quite so nasty, notice the pi r square factors. We remember that that's the area formula for a circle, and a cone is sitting here on a circle. So we're going to find the area of the circle and then multiply that by 1/3 times the height of the cone. Alrighty, let's substitute in the values that were given. R, of course, stands for the radius of the circle, and that's given as 3 centimeters. And the h here represents the height of the cone. So this is h. So into the formula we have 1/3 pi. I'll substitute in the 3 centimeters squared times the height, 8 centimeters. If we multiply 1/3 times 3 squared times 8, we get 24 times pi. Centimeters times centimeters times centimeters would be centimeters cubed. That's the exact volume of the cone. Using our calculator to multiply 24 by pi and rounding off to the nearest tenths, we get that the volume of the cone is about 75 4/10 cubic centimeters. Hello, this is Mrs. Workman. Zoe is giving party hats filled with candy to guests at her birthday party. Use the drawing to determine the volume of the hat. Use 3.14 as pi. Round to the nearest tenth. Notice that we're given the height of the cone and we're given the radius of the circle, which is its base. The volume formula that we'll use looks like this. Volume equals 1/3 pi r square h. Pi r square, that look familiar? Area of a circle. We're after the volume, and so that means we'll substitute in values for pi, for r, and for h. We were told in the problem to use the approximation 3.14 for pi. For r, we'll use 3, and for h, we'll use 14. Now I'm going to go back and erase this equal sign, and in its place I'm going to put this symbol, which means approximately equal to, because we're using an approximation for pi, the 3.14. Now is the time to pick up your calculator and do the multiplication and the division by 3. And if you do it correctly, on your screen you will see 131.88. We were told to round to the nearest tenth. So using our rounding off rules, we would now have 131.9. Now let's talk about units. The radius is given in centimeters, so this would be centimeter times centimeter, and the height is also in centimeter. So centimeter times centimeter times centimeter would be centimeter cubed. So finally, our answer is this. The volume of the cone is approximately 131 9/10 cubic centimeters. Hello, this is Mrs. Workman. Find the volume of the composite figure if h is 5 inches and r is 4 inches. Round to the nearest tenth. Let's look at our composite figure. I notice that part of the figure is a cylinder, and the other part of the composite figure is a cone. We have been asked to find the volume of the composite figure, so we'll use the volume formulas for a cone and a cylinder. The volume formula for a cone is 1/3 pi r square h, and the volume formula for a cylinder is pi r squared h. So if we want the volume for the entire figure, it would be V equals 1/3 pi r squared h. That would take care of the cone, plus, here's the volume formula for the cylinder part. Now before we do any substitutions, I'm going to go back and just make these capital H's so as not to confuse us all. And these are going to stand for height. We are told in this problem that the height of the cylinder is twice the height of the cone. So if I'm even going to put these in parentheses to emphasize that. So if I go back to the formulas and replace those capital H's with what's in the diagram, the height of the cone would be h, and over here the height of the cylinder would be 2h. So now, a lot of prep work in this one. We have 1/3 pi r squared h plus, and now we have the 2h. So I'm just going to go ahead, ordinarily we put the number, the numerical factor out in front, 2 pi square r squared h. So finally, for this figure, the formula that will give us its volume is V equals 1/3 pi r squared h plus 2 pi r squared h. Now we're ready to fill in the actual values. I'm going to begin using the approximately equal symbol because in place of pi, we're going to put the 3.14. R, we're told, is 4, and h is 5, and again 3.14 for pi, r is 4, and h is 5. So I've just gone straight across and made the appropriate substitutions. This is r squared h. Now that we've used our calculators, we found that the volume of the cone is approximately 83.78, and the volume of the cylinder is approximately 502.65. And adding those, we get that the volume of the composite figure is approximately 586.43. And I'm remembering we were asked to round to the nearest tenth. We'll use our rounding off rules to get that the volume of the composite figure is approximately 586.4. We know that units of volume are cubic. The units were 5 inches and 4 inches, so the units are inches cubed. So the volume of this composite figure is approximately 586 4/10 cubic inches.